Yes.
We can start. I was just waiting. Welcome, everyone. This is Margaret Mooney and Steve Ackerman from Madison, Wisconsin. And we're doing the follow-up webinar to the Sally Ride Educators Institute that happened at the end of February.
Hi, this is Steve Ackerman, just so you know my voice, and it's good to be speaking with you all.
We're going to do a short PowerPoint and then do some online tools. And then after our first 25 minutes or so, we're fortunate to have Preston Lewis from NASA Langley. And then Becky Reed, who is from a teacher in Santa Barbara, but also an important teacher working with the Federation, which is the Earth Science Information Partners, which helped put on the Educators Institute at Sally Ride at the end of February.
Hey, Margaret. Before we get started, maybe we see who's on, just do real quick, who's on the phone.
Okay. Who's on?
This is Mark Ross.
Hi, Mark.
Mary from Florida.
Connie from Michigan.
Janice from Massachusetts. Lisa from South Dakota. Mary from Florida. Anybody else?
All over the state.
A lot of geography. Nobody from California.
Oh, yes, I am. Mark is from California.
Mark, right?
Yep.
Okay, great. Well, that's the cool thing about webinars. If we can get them to work, we can all connect from all over.
Yeah. Big gift.
Well, I hope that you guys can see the PowerPoint right now, see our desk. It is going to be recorded. But what we're going over is the online curriculum that I was able to share briefly at the Institute. And so I have the URL and the front page of it, and I just wanted to reiterate that the online course that we've developed is consistent with Climate Literacy Framework that was developed collaboratively between NOAA, NSF, and several other partners. It was built to clarify content in the Intergovernmental Panel for Climate Change report that came out in 2007. We have a small report called Summary for Policymakers. It's about 18 pages long and a lot of fabulous graphs and tables, and we built a course so that basically anyone could understand that summary report. In 2010, we had funding from NASA to update this course, and educators or anyone can, for credit from the University of Wisconsin-Madison, we offer it one time a year, or you can take it and earn it that says you completed it. So navigating through the course, the top navigation bar has options. You can see the course outline, resources, lesson plans. We want to make sure that everyone visits those. You can log into the course and work through it, a certificate of completion at the end. There's 16 lessons, about 16 hours. It can take longer depending on how far you or as I mentioned, you can take it for credit once a year. I'm going to go through a lesson on a PowerPoint and then go through it online. Once you get into a lesson, a left navigation bar comes up, and every lesson has an introduction that says about how long it will take and what you can expect to learn in that lesson. Next, you would go to the concepts part of the lesson, and these concepts are meant to be interactive and not have a lot of text. You can see the example one we have. It's lesson 2. It works like a PowerPoint, basically. It says on the screen right now, down in the bottom, it says slide 2 of 11. So you have to turn the page, basically. You have to move it forward and read the next bit of information about the next graphic that's going to be in the lesson. And if you want, you can listen to audio, too. You notice the concepts, as I said, not a lot of text. We try to have a lot of activities. So you got the basic information, and then you can reinforce what you've just learned by working through activities. This lesson that I'm showing right now, if you can see this, is one that we revised last year with help from NASA Langley experts to show satellite data about 2 satellite missions called ERBI and Ceres, Earth Radiation Budget Experiment, and Clouds in the Earth's Radiant Energy System. Some of the stuff online. And then Steve's going to show some applets that interact about the Vostok ice core and the Milankovitch cycles. I'll just say that for now. And the other one is a carbon projection applet. So right now this is just a screenshot, but later we'll show it more interactively. And then every lesson also has a little quiz at the end. It's like 3 or 4 questions. If you want, you can just find out the answer and, you know, not get a certificate or not get credit, but they're pretty easy, and especially if you've just done the lesson. And now we're going to go online. So here, if you can see my our screen, we're online in the course. As I mentioned, you can get to the lessons either by going to the course outline or going to the units highlighted for you guys. I'm going to go to one that we just showed, and I'm picking Lesson 15, Climate Change Impacts in the Continental United States. This particular lesson, we revised it when we got that NASA funding, and it shows information from the 2009, let me go back there again, U.S. Global Climate Change Research Program. So they released a report that showed impacts by region in the United States. So I'm glad to hear that there's so many different teachers from so many different places. I was hoping this would be useful. And so now you'll see that the concepts page is coming up. And you see a little Java applet. So you have to have the most a recent version of Java. So if you have a problem with these concepts page, you just need to update your Java, which doesn't happen very often, but happens occasionally. So here we have the Pacific Northwest, and the key issues are listed in the text. And once again, I said this content is from that U.S. Global Climate Change Research report from 2009. So you can read the key issues for every region. I'm going to go through the different regions here. The Midwest, where we're from, the Southeast, and then you could also hit the audio. Oh, I've got my, yeah. Okay, so sorry about that. It's audio, but the annual average temperature in the Southeast. And it's just my voice again, so that you can't hardly tell that. But that's more, the audio is typically not the same as the text. It usually goes further. So, but this audio, you want to listen to it. And then here we have another graphic from that report that shows the increase in the number of days with very heavy precipitation. So what's interesting about this report is it's not climate modeling, it's not climate projections, it's like climate impacts that are already observable. So now I'm going to go to the activities section just for this lesson, and just sort of show you by example that many of them are very short activities. This is an interactive from the Union of Concerned Scientists, and it has different, I'll pick Pennsylvania, I guess. And it shows the migrating climates for the summer and the winter, starting with from 2003 to the end of the century. So I hope you can see that. It's kind of cool to kind of show in a quick little graphic how climate is expected to change by state. Once again, like I said, this is just an example. In this particular lesson, there's also this regional information that was developed by NOAA and the United States Global Change Research Program, where you can learn more about your region by clicking on these. I'm not going to do it right now, but I just want to show you what's available in most of the regions. And then, as I mentioned, there's the quiz. So you can log in to take the quiz. If you're going to get a certificate of completion or credit, you need to do that. Or you can just take it. And this is what they look like, 4 questions. This one only has 3 questions, 1 graphic. So I just also wanted to show you that for the teachers that have taken it for credit, they've developed all these lesson plans. So we've got them posted for middle and high school level. They're all 2 pages long. They're typically 1 class hour. So this might be a great resource for people. One particular teacher on the top here, I have an action plan, did an action plan for his whole district, so elementary, middle school, and high school, to do an activity around 10-10-10. So it was a carbon footprint activity for the whole district. So that's available for download. Next, I'm going to resources in this course, and there's several different resources, including, of course, other URLs that support the content in it. But I also wanted to show you that all the activities listed by lesson are available at the top of the resources. So if you went to the Sally Ride Institute, one of the NASA pages that we were demonstrating was the Earth Observatory. One of the best ways to get satellite data, recent, up-to-date, you can see it says it goes up to February 2011. You can see, stop it. It has related maps. So if you hit related maps, it's going to show you what maps are make sense to show with different data sets. And it's going to explain below it why they go together and what makes sense about showing them. So, moving down this resource, I wanted to show you another one that we emphasized at the Sally Ride Institute, and this is the NASA climate change site. And we have a ton of cool activities that we've linked from here too. So sea level rise. So once again, they're grouped by the lesson. So every activity makes more sense if you've done the lesson first, but it's also pretty resourceful otherwise. I guess at this point, I'll show you at the very bottom of this resource link. We have a link to some tools that are developed here at CIMSS called Atlas, and Steve Ackerman was one of the developers. He's going to take over here.
Yes, hi. I'm Steve Ackerman, and we developed these resources for a variety of educational reasons. Many of them were to address issues that I was having in teaching my introductory class to weather and climate for freshmen. And if you go back to the teacher lessons that Margaret talked about, you'll see that some of the lessons that they use make use of these applets. And we're very eager to distribute these. So if you see any you like, we're happy to point them and keep them on the web pages, or even give you CDs that you can download on your own. So I'm going to show you 2 or 3, depending on what the time is. And I'm going to pick some of the more complicated ones. Some of them are pretty easy and self-intuitive of what to do. But these 3 are a little complicated, so it's easier to watch somebody else go through what's available, as well as they're related to climate, which is what we're talking about. So this is the Carbon Cycle and Climate Change applet, and I'm going to first point down here where we have a map, and if you look over the images, you'll see that this is fossil fuels, which is a source of carbon dioxide into the atmosphere. We also have vegetation down in here, which of course is a sink with regard to the atmosphere. The ocean does uptake, and then we have biomass burning and land use, which affects the carbon budget. And as we go through the simulation, which is what we're going to run in just a minute, you'll see actually some of these will change in their size or in the amount of uptake in terms of the arrows here that I'm pointing to now. So if you look up here on the left-hand side, we have 1 curve up here, related to the sources of carbon dioxide in the atmosphere as well as the sinks. And these are figures you often see on the IPCC. And what we show here is in the orange, you can see it highlights how much it is in a year and the usage per year of fossil fuels. The orange is the actual amount, and then the green are projected. And the blue area here is generally the range of projections that they like to run in their climate simulations. The thing you'll notice about these green lines is that there are dots there, and so as a user, I can modify where they are. And so I can run my own experiment in terms of the sources of atmospheric carbon dioxide. And if we were here in face-to-face, I would have one of you do this, but I'm going to do it, so you can see. Now, over on the right-hand side is the plot of the actual atmospheric carbon dioxide in parts per million as a function of year. And again, the orange line is the current observations, and then the blue area represents the projections. And so the nice thing about this is once I decide what the usage is on the left-hand side, I can hit this run projection model. And when I do that, you're going to see changes over here in the right-hand curve in terms of atmospheric carbon dioxide concentrations. So here we go. I'm going to hit the button, and now you see a black line over here telling you the year, and then this is the corresponding concentration based on this projection that you made. And of course, if you were watching down here, you'll notice that the amount of smoke coming out of the smokestacks decreased, indicating there was less carbon dioxide coming out of the factory. And so this is a good way that people can play with various scenarios. You can do the classic one of, well, what if it remained the same? And again, run the projection. It'll do now a comparison. You'll see in the lighter green what the previous run was and now what the current run is. Of course, you'll notice fossil fuel sources is what's highlighted up in here. You can do other things as well. You can hit changing land use, and so now I have control of the different set of curves. So again, like scientists, then your students can run experiments where you keep one thing fixed, change something, run the model, and see what the impact is for that change. You can see trees down in here are now growing because of the way I changed the land use. And then if you've had experience running EdGCMs, I don't know if people have done that, but if you do, if you click this button, it'll take your output from this model run and set it up to be run directly into that education general circulation model. So that's one of the applets. I'm going to show you another one here on past climates, which is about the Milankovitch theory. And you'll see the first thing we do is we always remind the student that this is not to scale because people tend to think space is crowded, and we think it's because of these types of diagrams. We also can do a top view so you can see that it's more circular. You can stop the rotation of the Earth as well as stop the orbit. Then what you can have control of here is the change in the tilt. I'm sorry, let me come back to that. On the right-hand side here, as Margaret pointed out, is the Vostok ice core. So again, this is in terms of now going down to 400,000 years ago, what the temperature was. So you can see most of the time it's colder than present day. And you have a slide here that you can grab. You can see that I'm pulling it down, so you can see what the values are. Now, the other thing that you can do with this is if I come down to the bottom in here and I hit the eccentricity button, you'll see now that there's a purple line. So the eccentricity varies throughout, I think it's a 100,000-year cycle. And so the idea here is you can look at the changes in the temperature and see how they line up with these periodicities, in this case of eccentricity. Or you can add precession, and you can add tilt as well. Now, the other thing, I'm going to unclick them, just click eccentricity. Then what happens is I can grab that triangle again, and then as I move it through time, you'll notice the orbit is changing. So it's giving you an idea of what eccentricity is doing. And then I can do the same thing about the tilt. If I hit the tilt on, you can see that the tilt varies by a couple of degrees. throughout, I think it's a 40,000 year cycle. And then my favorite is actually the precession that tells you how it's pointing as you move through it. So you can see actually we're going through the different seasons as it goes through its variation. And so, again, the idea is that when you put all of these on, you can begin to look at correlations between when you have peaks in this cycle, which is going to impact how much solar energy you're getting, and how that correlates with the Vostok ice sheet. And again, teachers have some examples of how to use this as an activity in teaching. And then the final one I want to show here is the hurricane, because there's a lot of talk about the relationship between sea surface temperature and hurricane strength. And so the thing that I like to do with this is actually have students try and get the strongest hurricane they can. So when you see a number appear, that is the hurricane category. So this is a Category 1 storm right now. And students, as you can see, have control of where they can pick it up and where they can move it to. And they also have control of the season, so they can pick the season. And the idea is, how do you get a Category 5 hurricane? So you can see the relationships between sea surface temperature and hurricane. And it's actually pretty hard to do, except one student was smart enough to cheat and basically hold it over very warm water for a while. And then eventually it turns into a Category 4. The other thing that they have control of is the steering currents as well. So they can generally try and steer it over the warm water in order to get it up to a higher category. And then you'll usually have a reset button. You can start all over if you get lost. You'll notice the sea surface temperature is also plotted down here. And actually, if you put it up to cold water, it goes away real quick. And if you put it over land, the hurricane also goes away real quick. So that's an example of 3 of the activities that we have that you can use in teaching about climate. And the other ones are primarily about weather, but they're fun to do as well.
Okay, I think we're ready to hand it over to Preston.
So good.
Okay. All right, I'm passing it on.
Okay. Okay, go ahead and get started. We're going to go over a couple different things. With MyNASAData, we're primarily going to look at some different data visualization features that we have built in and are being used more and more often. And we're going to do 3 different ones. The first one is plotting to Google Earth. The second one is getting MyNASAData into Microsoft Excel so you can manipulate the data. And the third one is a fairly new one. It's called a color plot comparison. This particular presentation has examples from 2 different lessons. It's hurricanes as heat engines. That particular lesson actually looks at the heat that the sea surface temperature as the hurricane passes, and it has the students look at the drop in sea surface temperature and then its rise again back to what its normal state is. The second one is solar cell availability from across the country. This is a problem-based learning activity where the students get to look at surface radiation and compare the radiation to latitude and longitude changes. And what they get to choose is, or the situation is that they have a solar-powered RV and they're a rock star, and that they have to choose a tour along the United States. And the key is that wherever they go at any particular time of year, there has to be 100 watts per square meter of energy, and they have to choose basically off the top of the head where they want to go, and then they go into the MyNASAData live access server and begin to make those choices and see if where they want to go works. Inevitably, they'll want to go somewhere in the wintertime and realize that in the further north you go, the shorter time you can spend. But between these 2 lessons, all the examples that I'll show you will be present and I'll actually walk you through. Some other plot options that we have that you can use, as you see right here, this is the MyNASAData Live Access Server. The first one we're going to do is plot to Google Earth, but you do have a lot of other choices. There's interactive color plot, which allows you to actively select the location. A color plot, which is very popular with the teachers because once they go through and do a lesson, whenever they plot something, they can save that image as a picture and use it in a PowerPoint or on a Promethean board or however they show things to the students. There's a color plot comparison that I'll show you later on. There's a .net/PDF file. That one's not used very often in the classroom. There's a text file, which we'll show you later on. That's actually one of the first steps in getting your information into Microsoft Excel or other plotting programs. R2 gridded, if you have GIS capabilities or you know how to manipulate that data, that's available. And the last two have to do with Google Earth. So we'll go ahead and start looking at Google Earth. Typically, with all the MyNASAData lessons, they all will eventually lead you to the live access server. So for each one of these examples, this is going to be the starting point. And if you guys have questions, you can ask me at the end, or you can shoot me an email. I'll show you that. So when you decide that you want to plot something to Google Earth, there's only one change that you have to make, and that's going to be in the output. Typically, with most of the lessons, the output is going to be a color plot or a time series that allows students to visually look at things in the plot form or color form and compare those to other plots that they choose. So here, when you're in the live access server, and if an option is to look at a color plot, it's easily changed to a Google Earth file. And all you do is from the select output, you choose that as your option, and then you click next. And then it'll prompt you to do new things. I have a Mac, so I took a screenshot of that, but it should be about the same for a PC. In this example, it allows you to go through and save the files or automatically open it. My preference has always been to save the file and then go through and in Google Earth open it up that way, but you can do it either way. Once you do this, you save the file to your computer, and you can rename it if you'd like that way. If you don't want to go back to the internet, you can always just save it on your desktop however you like. Once you do that, the next thing will be to open it up in Google Earth. This particular one came from the Hurricanes' heat engine, where it looks at sea surface temperature, and in this particular one, they're looking in the North Atlantic. And as you see here, this is a nice image on the globe where you were able to select what the live access server calls the North Atlantic and begin to look at the time that you would have chosen in the live access server and plot to Google Earth. The nice thing about this is you're no longer looking at a Mercator projection like a lot of things are in the science classroom. This allows you to spin the globe, zoom in. So if you're looking at a particular island in the Atlantic, you can rotate the globe, zoom in, and you'll be able to have a better idea of the exact sea surface temperature. And with all of these, when you plot to Google Earth, there will always be a key next to it, so you can compare back and forth. And the nice thing is when you download multiple files to Google Earth, all you have to do is select. So if you select them on and select them off on the left-hand side. This next slide shows the difference between the two. The one at the top left is the traditional MyNASAData color plot, and the one at the bottom right is the plot to Google Earth. They both have their value in the classroom, but as teachers try new things or students ask what they can do differently, Google Earth is a good way to begin adding a new layer of difficulty or a new layer to your presentations and how you present things in the classroom. But again, either one of these can be saved on your desktop and reopened. The Google Earth would have to be opened as a file, and the color plot can just simply be opened as a colored image. The next one is Microsoft Excel. This one is a little bit more complicated. On our website, there are different tutorials that will walk you through step by step. So you'd go from the very initial step of getting to the live access server, and it'll walk you through. It'll tell you to click on Atmosphere, and then it'll tell you to click on atmospheric radiation if that's what you want to look at, and it'll walk you through step by step on how to get there. The one thing you need to remember is if you pick this up and you want to do this on your own, the one thing you have to make sure you select is text file. When you download this as an output option, the computer will recognize it as an output file and save it so that Microsoft Office can open it later on. What you do here is simply select text file, and then what you can do is you can select all your other parameters. For this particular one, I chose a 10-year time period. It's becoming more and more popular to look at longer and longer data sets in the classroom when the topic of climate comes into play, especially when you're trying to show the difference between weather and climate and how they're related and how they're not related, and emphasize that to the student. So for this particular one, we will be looking at sea surface temperature. This will actually be in the Gulf of Mexico from 2000 to 2010. The great part about this is you can have students can make connections between the plot that you'll produce and events of notice like Hurricane Rita, Hurricane Katrina. The nice thing is that they'll be by date, so you can pinpoint exactly when a hurricane might have gone through and have them circle on the map or whenever they finish and begin to say, okay, well, when was the 2005 hurricane season? They can circle it and begin to look at sea surface temperatures. Once you've selected the ASCII file or the text file, it'll come up with a new web page and it'll look like just some print on it. The thing to do here is go up into your file menu, choose File and Save As, just like this right here. And you want to always save it as an ASCII file. And the one thing I will recommend that if you want to use this, I recommend not changing the file name. The reason I say that is because sometimes when you change the file name, Excel won't always recognize that it is a text file and you'll have a hard time opening it. So once you have saved the text file, make sure you remember where you save it, and then save it as an ASCII file, and then all the rest of the work will actually be in Microsoft Excel. Once you go to Excel, the newer versions, it's much, much easier than some of the old ones. With the newer versions, there's an icon, if you see in the upper left-hand corner of the screen, there's a little button that says Import. Once you click on Import, this will give you all the different options. And here's where after you click it, you'll be given a set of 4 options. And because we want to look at a text file, and that's what it was originally saved as, this is the one that you select. And I think on both a Mac and a PC, you get a radio button, and then you select the radio button, and then you're going to click Import. Once you click Import, typically there's nothing else that you need to do other than follow the on-screen instructions, and there's nothing you need to change. So while there might be multiple prompts asking you questions, all you do is click Next or you click Finish, and it'll automatically put it into Microsoft Excel. In this particular one, it'll show weekly data, and as you see here, it shows there's 4 weeks in the month. There'll be 4 different data sets. So you get an average for each week, and then it'll give you the coordinates, or in this particular case, the date and the sea surface temperature in Celsius. Once that's done, the typical thing to do would be follow the normal instructions for plotting something. It's become easier and easier, and the way that I do is I highlight all the data, and I just go to Create Chart, and once that's done, you get to manipulate it. And this is the exact example that I did. I didn't do a whole lot of changing. I just wanted you all to see exactly what you get as the very first primitive step in creating an Excel plot. The nice thing about Excel is that because in the classroom you're still limited to time, you always want the ooh-ah factor for your students to see, and I think Microsoft Excel lends itself to that very well. It does so because it allows you to expand, contract, and have the students look at the data points right next to the plot that you create. It also helps them begin to make sure they have all the correct parts on the plot, a key, a title, the X and the Y axis, make sure they're all labeled, and that way they get the idea that if anybody picks this up, they'll be able to understand it. The other alternative to an Excel plot in MyNASAData is going to be just plotting it to a time series plot, and that's what you see in the bottom right-hand corner here. With this one, you're limited to what the live access server gives you. With Excel, you can have a max set, you have a minimum set, and it allows the data to be more magnified, and you can get a better sense of the trends. An example here in this one that I chose, in very early 2001, there was a missing data point, so the live access server actually gave it a mark of 0, which throws the plot off. The good thing about Excel is if you see that it's a missed data point, all you have to do is go in and delete it, and it auto-corrects itself in the plot, which allows it to be much easier to view and look at the different numbers. As you can see, the one that was done in Excel, it has a much shorter range, whereas the one in the live access server, because it did count that missing data point as 0, it gave you a much larger range, which made it very difficult to look at the individual points. One of the other nice things about this is, depending on the level of student, you can have them go in and create multiple Excel graphs and have them compare them. You can do this by region, or you can have them study latitude versus longitude and how those changes affect the parameter you're looking at. And the nice thing about this one is, as long as you can make a time series plot, you can always create an Excel plot for it as well. And the other nice thing is, with Excel, you can add multiple data sets on top of it. So if you want to look at sea surface temperature next to precipitation, next to sea level height, and plot all those on the same one, so the students begin to make correlations and see if anything's related, see if things are in phase or out of phase. It's very simple to do. All it is in your Excel plot is just adding one more line and going through the same steps, highlighting all of them and beginning the process of labeling. And again, if Excel intimidates your students, there's always tutorials on the MyNASAData website that are very easy to find. The next tool is one of our new ones that we've added on there. It's color plot comparison. This is nice because it allows you to look at multiple individual color plots right next to each other. And for this one, it's as simple as all the other three, is just going to the output. And here, all you do is select color plot comparison. So if there's an example, a good example came from the hurricanes and heat engines lesson. This particular one, the original instructions had the user go through and select just color plot and had them generate 12 of them. Now with the addition of the color plot comparison, it allows them to do all this in one step. So once you choose your location and your date, you choose color plot comparison, you click next, you get a large screen. This particular one, I actually did average temperature, and this one looks at the basically North America and the little bit of water surrounding it. It might be hard for you guys to see, but I chose 2005, and what I did here is I have 12 different windows. So as you go from left to right and work your way down, you actually get to see each month of the year. So these are monthly averages, but it allows the students to begin looking side by side at the different months so they can sort of see the gradual change in seasons. Or another really useful place for this is when studying El Nino and La Nina. It allows the students to look up different years and look at sea surface temperature and see the subtle changes in ocean temperature as you go through the seasons. And this allows you to almost look at this in a frame by frame instead of an animation that might be more difficult for them to see an individual time period. This allows them to slowly look at it. And the other nice thing is, because each one of these can be saved as a image file, they can actually use photo editing tools or use PowerPoint and turn it into an animation by making it into a slideshow that advances itself. I know a lot of the workshops I've done, that's one of the more popular things for teachers to do. That way they can set the time that they want their animation to run at and then move forward and allow students to manipulate it. I think that's about all I have. Are there any questions? I didn't want to overwhelm people with doing too many different things, but there are any questions, I'd be glad to take them. Is there a question?
I unmuted everybody and I got quite a bit of noise. I'll do it for a second and see if we get anybody. If you have a question, just speak up when I unmute everybody. Okay, any questions?
Can you hear me?
Yes,
Yes, I can.
Okay. I can't see what you're doing. I've tried a number of times to get on to be able to watch it. So are the links what you're talking about in any of the materials that we were sent?
I am not sure, but I can make sure that I send it to Margaret or Aaron.
Because I would really like to see what you're talking about. I've done some work with sea surface temperatures using some of the NOAA web links, and it sounds really good if I could just see it. I've frozen my computer up 3 times and had to restart it to try to see if I could get anywhere, and I'm convinced that it's not going to happen, at least not now.
Have you ever used something called Live Binders by chance?
I have
Okay,
not.
what I'll do is I'll include a Live Binder link. What a Live Binder link is it's an online tool that is basically like a collection of links that allows you to visibly see them. So what I'll do is I'll include this PowerPoint in that, and you can download it, and it'll have all the other links under tabs that you can go through, and I'll have one for live access server. So it's kind of a one-stop shop for MyNASAData in this particular presentation. I'll also include the one for hurricanes as heat engines and the solar cell availability. So you can download both of those lessons and look at them and compare that to this one to see the different data tools.
Okay, fabulous. Thank you.
Yeah, not a problem.
Anybody else? Cool. Well, I guess, Becky, if you're ready.
I'm ready.
Okay.
Do you give the presentation to me, or do I snatch it?
I'll give it to you. And thank you so much, Kristen, for being on the call and sharing all of this.
Yeah, not a problem.
Becky, you're beginning, and I'm going to mute everybody again.
Okay. My name is Becky Reed, and I just want to check with somebody who's not unmuted. Can you see my screen, and can you hear me?
Can hear you, but can't see your screen.
Okay.
Click the share desktop.
Waiting. Hold on. Aha.
I'll now mute myself.
Okay. I think that you can see my screen now. Hello, everybody. My name is Becky Reed, and I'm a teacher in Santa Barbara. I went to a couple of the ESIP summer meetings and got the idea that we, the teachers who went to these meetings, needed a format to be able to share our ideas with each other after we got home. And we've added the Sally Ride Climate Change Institute teachers to this group. This is a wiki. Everybody wants to know what a wiki is. A wiki is basically a collaborative website. So instead of a website that you just go to and look at things and maybe download some things, a wiki is a website that asks its members to also add content and create some things on there, maybe even interact with each other. So you can probably see that there's, welcome to the ESIP Teachers Wiki. It has 2 ESIP meetings that were there, but you can scroll down to click to the Sally Ride Climate Change Institute link, and you can go there to begin to look at some of the Sally Ride climate change content that we got at that institute. It's a work in progress. Not everything is up there, but I will just click that and let you see what's doing with that. So there's the presentations that we all got to see, and then there are links to individual pages for each of those. You can click one of the links, it will go to an individual page. There's not much there yet, but the most important thing is the idea of leaving comments. You can leave comments at the bottom about what you thought about each of those presentations, maybe how you're using what's happening in those presentations in your classroom. So I'm not logged in yet. I just wanted to show you what it looks like when you're not logged in, because that's what you'll see when you first get there. I'm going to go back to the wiki main page. So you can get to this wiki by going to ESIP Teachers, which is ESIP Teachers.pb, as in peanut butter, works.com. You'll see the page that I'm seeing. You'll be able to read all the content, but you will not be a member until you request access. And over in the upper right-hand corner, it says to join this workspace, request access. You can do that. Or if you already have an account, log in. Some of you may already have an account. If you signed up at the Sally Ride Conference, or if you got a invitation email from me. So I'm going to just go ahead and log in. You will use that email that you used to sign up. You'll use that, and then you'll enter a password. And the website asks you just to create your own password. You'll have that. And then you'll be logged in. You'll be a member. Again, if you're not a member, the easiest way to do that quickly is to just go to that site and request access. So when you log in as a member, you'll be able to add things, create content, put comments at the bottom, so that at the bottom of every page there's a comment section. We want you to be able to continue the conversations that you started at the conference, or any of the conferences. And so there is a place for it to join the conversation over in the sidebar, or up in this box where it says join the conversation. Either one brings you to the same place. And there's the ESIP Educators Forum, where that's just kind of a chat area. It's a discussion board. You can talk to each other. It's informal, maybe just a shout out to somebody that you met there, or if you want to post pictures from the event, anything like that. There's a separate login for the forum, but you can use any other login that you already do, like Facebook or Google. So you don't have to create a new persona for that. I'm going to go back to the wiki page. Anytime you want to go back to the home page, you just click up in the upper left-hand corner to go to wiki. You can see things like submit a lesson plan and review a lesson plan in the middle, and that's really where we want you to participate and add content. So say, for example, you got some really great ideas from one of the presentations at the Sally Ride Conference, and you created a lesson plan out of that. You put things together, you presented it to your students, they had a great time, they learned a lot of things. We want you to share that with the rest of us so that all the rest of us teachers can modify your lesson plan, use it straight up. It's just a way for us to all share with each other. So you would go click submit a lesson plan. And there's instructions about how you can use a template that I have on the wiki to just submit all of the things that you've done when you created a lesson plan based on something that you saw at the Sally Ride Conference, or anything that you just saw here today. Any of the lessons that you might have gotten an idea from what you just saw on this webinar. And then you would upload it to the site so that other teachers can use it. If you do that, we have a thank you for you. Through funding from ESIP, we're able to give you a $50 Amazon gift certificate. Just a thank you for both creating the lesson plan and then sharing it with everybody else. So we want to encourage you to do that, and that's one small way to encourage you to do that. And another way to get yourself an Amazon gift certificate is to actually review a lesson plan. So then you would click on the Review a Lesson Plan link. And rather than some reviews where you just read the lesson plan and say what you think about it, we want you to actually try it with your students. And after you try it with your students, then you'd come back in and tell us all how it worked what you did to modify it. Maybe you have different age group students and you modified it that way, or you know that it had to be modified in some way for your students. Put that on the review a lesson plan. We'll also give you a $50 Amazon gift certificate for doing that. And that's all thanks to ESIP and their funding. So I think that's what I have to say about that.
Cool. I guess I'll unmute everybody again, and if you have a question for Becky or Margaret, if you're still on, I'm going to, if people have any questions for you too. I'm muting everybody. So any questions for Becky or for the first presentation, Margaret?
What is ESIP?
ESIP is the Federation of Earth Science Information Partners, and basically it's just a network of scientific researchers, Earth Science data centers, and application developers that come together twice a year physically, and then the rest of the time online to work on improving Earth Science data usage. So in the classroom is one example of how that happens, but also for all kinds of other purposes.
Yeah.
And maybe, Margaret, you want to give a plug about the summer meeting?
Sure. So NOAA has supported time and travel stipends for teachers who want to attend the summer meeting. This year it's in Santa Fe, New Mexico. All the places, I doubt that that's going to offset your travel, but if you were going to be in New Mexico in July, the ESIP Teacher Workshop is July 12th, Tuesday the 12th, and Wednesday the 13th. And we will have, we have 9 presenters lined up already. The essential theme is going to be climate change, but it's going to be much also broader and touch on a lot of earth science applications. ESIP is a national network, and so these are going to be members from all over the country meeting anyways, because they're already traveling to this location. The ESIP Education Committee has chosen to have a teacher workshop co-located with the ESIP meeting, and NOAA has supported time and travel stipends for teachers to attend that the meeting there. And that's, like I said, it's only $200, so it's really meant for regional teachers. Anything else?
Going on. So like we've mentioned, this call was recorded, and so if you want to watch any part of it again, it'll be online. And all the materials, I think, Becky, we can maybe say, we'll put them, so the live binder and all of that stuff will go out in an email, but we'll also put it on the ESIP Teacher Wiki as well. I think if there isn't anything else, thank you to all of the speakers and to all of you teachers who are on the phone.
Hey, thank God the phones still work.
Exactly. Sometimes less technology is better.
This is true.
Anyway,
Thank you,
have a good
everyone.
rest of your day.
Right.
Yeah. Thank you so
Good
much.
night, everyone.
Margaret, thanks, everyone.
Take care. I feel like the Waltons or something. Good night, everyone.
Good night.
Good night from Michigan.